Okay, there we go. It always starts at full volume. Okay, there we go. I'm not good at intros. I probably should think about that. How can I clear the parent? Alt key? Clear parent? Type clear parent. Alt key. Clear parent. Okay. Parents are cleared. So now I go into pose mode. I select the bone that I want, and I go back into object mode, and I select that, and then hold on. I need a YouTube video. It's unfortunate. I think I need a YouTube video. If Firefox would actually not glitch out, oh my gosh. I'm gonna have to close. Oh, that shut off the music. Can I not do open new window? Okay, there we go. Can we turn back on the music? And there we go. Okay, now. Okay, Sharpwind is a good person. I'm. Do I have to freaking? There we go. History. This guy. Okay, finally. Now, where was it?
Widget skinning is used when your character is made up of multiple symmetrical objects and none of them deform. They just move along and rotate. You'll often see these kinds of rigs on robots. The way you do this is by hopping into pose mode on your rig, selecting the bone you want to parent to, then hop back into object mode. That bone is still technically selected, so now you can select your object, or multiple objects. Then select the armature last, so the armature is the active selection. Press Ctrl P to parent, and select bone. So
Okay. Armature last, and then Control P to bone. Okay. Now if I'm in pose mode, that worked. Oh my gosh, that worked. That worked. That worked. A little bit of a head tilt. That worked. Okay, finally, I have something. Okay. So, pose mode. Okay, is there hotkeys for mode switch? Tab switches between okay. Mode hotkeys. Perfect. Okay. You know what? I need to be more specific. Pose mode. Oh wow. I'm literally going to the next page of the introduction. Here we go. There's no hotkey to switch from object mode to pose mode? Oh, okay. I accidentally discovered that. Control tab. Control tab switches from pose mode to object mode, and regular tab switches from edit modes to object mode. Sorry. Control tab pose to object. Tab object to edit. Okay. Experimentation. We got it. I'm gonna move you to be right there. I'm actually gonna minimize the music. Oh. Yeah, I guess 30 is an okay volume. Okay. So what's next? Control tab select. Control tab object. Select armature. Control P bone. Okay. Control tab pose. That's connected. That's connected. We're connected. Okay. Control tab. Select bone. Control tab object mode. Select object. Then select armature. Control P bone. Control tab. Heck yeah. Okay. So, pose mode, control tab, select object, select armature. Oh, hold on. Control tab. Okay, pose mode still selected. Control P, bone. Okay. Control tab, select that bone. Control tab, select that object, select armature, Control P, bone. Okay. Control Control Control. Okay, so only when the armature is selected can you do Control Tab to switch from object to pose. Okay. Object. Control P, bone. Okay. So now, armature selected, go into pose mode. Heck yeah. Heck yeah. We got our leg, boys. We got our leg, boys. Oh yeah. Okay. Okay, so now we select that mode, object mode, select, then armature last, Control P, bone. Control Tab, go into pose mode again, select the bone, object mode, select the object, select the armature, Control P, bone. Okay. Control Tab, select the bone, Control Tab, select the object, select the armature again, Control P, bone. Okay, so now, now now we got legs that work. Cool. Cool, cool, cool. That arm. Control tab, object mode, select, armature last, control P, bone. Close mode, select other bone, control tab, select armature last, control P, bone. Bone, control tab, select, control P, bone. Oh no. Oh no. That foot shouldn't be selected. Ah, I see where the problem lied. Armature, control tab, so that bone selected. Bone, armature, control P, bone. Okay, cool. Cool. This is why we test things. So bone selected. Control tab. Select object. Select armature. Control P, bone. Okay. Select bone, object mode, object, arbiter, control P, bone. Wonderful. Nothing is the matter. Okay. Bone, control tab, object, armature last, control P, bone. Okay. Armature, pose mode, select bone, control tab, object mode, select object, select armature last, control P, bone. Okay. Armature, pose mode with control tab, select bone, control tab into object mode, select object, armature, control P, bone. Okay, so now turn mirror off. Uh-oh. Okay. Select bone. Okay, bone is selected. Bone is selected. Control tab. Object selected. Armature last. Control P. Bone. Okay. So that's following that bone now. Control P. Bone. Okay. Armature. Wonderful. 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 all of that is connected. So I have the objects connected to the armature. I'm gonna finally put the lid on my key. Okay. So now I gotta get all of the bones. I need a new bone. 50. Hey. Armature. Zero. Zero. Now this armature, I want to... No. I want a Y 90 degrees. I want to show axes. I want my X to be facing upwards. Okay. G, X. And I need to have the armature. And then Control P to the bone. Yeah. That, I mean, that works. Oh. Oh. Edit. Yeah, I can scale it in edit mode. So that will... want you to be back at 0, 0. Mhm. Okay. Okay. No? Okay, so how do I get it to not be like that? Okay. Bone? Oh, Ugh. That's not right. Um... I feel like I did this wrong. Huh. Oh, my brain. My brains. My brains. There's a fly in front of my screen. Why can't I select a parent though? Keep offset. Okay, that that worked. I think. Uh, okay, there we go. There we go. Okay. I had to be in edit mode. Wonderful. And those are parented to that. Okay. Oh man, that was weirdly more difficult than I thought it would be in my brain. My brain space, it was cooked yesterday, it's cooked this morning. And we're only 40 minutes into the stream. Oh boy. Oh. Oh yeah. So, well, what do we have here?
All these objects are now parented to the selected bone. Alternatively, you can select all of your objects, then select the armature last, press Ctrl P to parent, and then pick Parent to Armature with empty groups. Technically, all these objects are now parented to the armature, but they're not assigned to any bone, so far nothing happens. Now, however, the objects receive new vertex groups in the Object Data Properties tab, and those groups have the same names as your bones. Here's another reason to keep your bones nicely renamed. I always say organization. It makes things so much easier. Now you can select all the objects, hop into edit mode, then select them with the L shortcut. Then in the vertex group, select the bone you want to parent your selection to, make sure the weight is set to 1, and click assign. You've technically weight painted this entire object to that bone by giving it a value of 1, so now it's gonna move with it. There's much more visual ways to weight paint, and we'll do that in a second. Don't worry, just wanted to show you this. Once you do this for every object, you should have a rigid rig that moves the parts around without deformations. If you want deformations though, you need to do weight painting, which I've mentioned before, which is where bendy skinning comes into play. As mentioned before, weight painting is a method of assigning weight to different vertices on your mesh to the bones on the armature to ensure proper and wanted deformation during the animation. That was a heckin' rhyme I did. This bone will affect these vertices by this much, and that bone will affect those vertices by that much. Again, we sort of did that in the previous step. We just assigned the maximum weight to full objects. Now we're just gonna do it with a brush. Okay, assignment time. To rig this guy, first make the middle row of bones, starting at the crotch, so that's our main root bone, and rename all of them. Now make one of the sides and rename that as well. Select all the bones on the sides and press Ctrl and F2. Since F2 is a shortcut that renames things, and Ctrl and F2 is a shortcut that batch renames things. It makes sense. Set this box to selected and bones. Set the type to set name, and the method to suffix, meaning it will add something at the end of the word. That's what a suffix is. Put the name to .l, which will add a .l at the end of your existing name. It's important to put the dot before the L because that's how Blender recognizes namespaces, which will make the next step possible. Select the side bones and then right-click and click Symmetrize to mirror the bones. Because of the naming convention we used, the bones are flipped and the .l turns into .r automatically, so the naming is all done. Just a tip. Now that the armature is all set, we need to bind it to the model, and the simplest way to do this is to select your model, then the armature, press Ctrl P to parent, and here choose Parent to Armature with automatic weights instead of empty weights this time. This basically did the weight painting automatically, which is very cool, but it's not the best, so we'll probably have to tweak this later. But for now, your model moves! Woo! This step also works with multiple objects at a time. Now to fix the weight painting, we need both the model and the armature selected, but the model has to be the active selection this time, because weight painting is an attribute stored on the model, not on the rig. So select the armature first and the model second, and then, through Control Tab or this drop down up here, enter weight painting mode.
Wait, hold on, so I must have heard Control Tab in my brain at some point, and I just wasn't actively listening. I didn't discover that. That was my brain thinking I did something clever, but I didn't. I didn't do anything clever. I actually listened to a video for once.
Here you'll see a rainbow. In short, the highlighted bone is the one you're painting the weights to, and the colors represent the weight itself. Blue is 0, meaning no influence, and red is 1, meaning max influence. To switch between bones, hold down Alt and click. You have a brush where you can press F to change the size, or Shift F to change the strength. Additionally, you have the strength slider at the top, as well as a weight slider. So the weight slider is the weight you want to paint, and the strength slider is like an opacity for the brush. If you want to fix the weight painting, you're basically trying to paint more or less effect in different areas for each bone. For example, here it's dragging too much of the behind, so I'm painting that out. It's always smart to pose the bone first and then do the weight painting on the pose, so you already see what it's going to look like when it's deformed, and it's easier to see where all the issues are. You might run into deformation issues in places where you don't have enough subdivisions, since deformation happens on the vertices. Simply add more, adjust your weight painting, and it's all gonna be fine. To paint the weights from scratch, parent your model with empty groups. Hop into weight paint mode, and in the options drop-down, turn on the auto normalize option. Since each vertex can be influenced by multiple bones at once, this option will limit the weight, so the maximum it can have across all the bones combined is always going to be 1. That means if you paint over an area which is already assigned to a different bone, the value will be taken away from that bone to accommodate for your brush stroke. Once you have this set up, select the root bone and paint the whole model. You can make use of the gradient tool by dragging it away from the mesh so it all turns red, and because of the auto normalize option, this bone is now the only bone with any effects on the mesh. Then select the next bone in the chain and paint everything from its effect up, which will take that away from the root bone. But that's fine since the root bone is still the parent of this bone, so when you move it, it's gonna look normal because it moves with it. It doesn't matter. Then simply move up the chain and paint each next bit until you have the weight painting all done. You can help yourself with masks. Select your mesh, hop into edit mode, and select the area you want to mask out. With this area selected, exit edit mode, so these vertices are still technically selected just like with the armature before. Now select the armature and mesh and hop into weight paint mode. Because this area is still selected, you can use it as a mask up here, either by showing you the faces or the vertices. It's just a display thing, they both do the same thing. So now this is the only area you can paint on. This is useful if you want to use the gradient tool to help you paint, but you don't want to mess up the rest of the model. Anyway, here are some other weight painting tricks you can use. You can assign automatic weights only to the selected bones, by first selecting them in pose mode, then going back into object mode. Then select your character, hop into weight paint, then open the weights dropdown and click assign automatic weights from bones. This will give automatic weights to selected bones, but will leave your other bones alone. You can drop down the display option and turn on wireframe to see the paintable vertices easier. In tool settings, there's a symmetry option, which is the same as the one up here. This will basically mirror your paint strokes. To smooth your weight paint a little, drop down the weights dropdown and click smooth. And once the model is properly weight painted, we can create some easy to use controls, which is where rigging really comes to life. There is no right or wrong way to create controls as long as they make all the required movements possible and simple to animate. So I'm just gonna show you a bunch of useful ones and you do with that what you will. Okay, let's make an IK handle. An IK handle is a control on the rig which dictates the endpoint of a bone chain. In order for it to work best, it also requires a pull vector so it knows which direction to make the bends.
I get that.
The IK handle, I'll extrude this bone out so both the bone heads are in the same place. Then I'll make the bone disconnected, remove its parent in the bone properties tab, and rename it. Now because this is a controller bone,
Wait, hold on.
also requires a pull vector so it knows which direction to make the bends. So to create the IK handle, I'll extrude this bone out so both the bone heads are in the same place. Then I'll make the bone disconnected, remove its parent in the bone properties tab, and rename it. Now because this is a
Okay, so select the head, extrude out, remove parent. Okay, that. Remove parent. IK dot L. IK dot R. Okay, so that's mirroring.
controller bone, it's not actually binded to the mesh and it's not going to deform the mesh, I'm going to tick off this deform option.
Tick off the deform option. Okay. What next, Mr. Man?
For optimization and for when you're exporting this rig into other softwares, but it's a good practice to have. So turn it off. For the pole vector, I'll extrude the bone from the bent joint, also disconnect it and remove its parent, rename it, and bring it out in front like so. Then also turn off the deform. Turn it off. We now have the required structure to make.
Does this have the deform turned on? Yes, it does. Does that have the deform turned on? Yes, it does. Is that? Yep. I'm turning them off. Turning them off. They're off.
Make the IK controls. Hop into pose mode and select the bone pointing into the IK handle. Now open the bone constraints tab. This is where you create different constraints, rules, and conditions for the bones, which can make really smart control systems. Click the drop down and add an inverse kinematics constraint. For the target, pick the current armature, and for the bone, pick the IK bone. If the IK bone doesn't work, just move the middle joint forward a little so it knows in which direction it has to bend. I've had similar issues before and I look like a total idiot. I don't get it. I don't understand. What is wrong? Technically, it should work now, but we're not done yet. For the pole target, also pick the armature, but for its bone, pick the pole vector bone. Your bone chain might flip around, so just mess with the pole angle until it's pointing back where it should, and also set the chain length to the amount of bones you want to be affected by this. In my case, that's 2, so the shin and the femur bone. So now the IK handle will move the end point of the leg, and the bend will always point towards the pole vector. You've got perfect control. However, the foot is now rotating with the shin. We don't want that. Let's make it so that we can control the rotation of the bone with the IK handle as well. In edit mode, disconnect the foot and remove its parent. Then in pose mode, give it a child of constraint and make the parent the IK bone. The foot.
Okay. Constraints. Add child of target armature IK left. Hold on. Hold on. Hold on.
Is no longer affected by the shin, but it's instead mimicking the IK handle bone. So the IK handle moves the leg and also. So, in edit mode, disconnect the foot and remove its parent. Then in pose mode, give it a child of constraint and make the parent the IK bone. The foot.
Foot disconnected. Not connected. No parent. Constraints. Not doing it.
Is mode handle as well. In edit mode, disconnect the foot and remove its parent. Then in pose mode, give it a child of constraint and make the parent the IK bone. The foot.
In pose mode. In pose mode. Control. Okay. Pose mode. pose mode. Constraints, add constraints, child of, object, armature. Okay, why is it not letting me pick the armature?
Foot is no longer affected by the shin, but it's instead, and make the parent the IK bone. The foot in pose mode, give it a child of constraint, and make the parent the IK bone. The foot is no longer affected by the child of constraint mode, disconnect the foot and remove its parent. Then in pose mode, give it a child of constraint, and make the parent the IK bone. The foot is
Oh, but that that doesn't look right. I don't think I can do the IK handles. I don't get it. I don't get why that's moving when I go in between edit and pose mode. That makes me nervous. That makes me nervous. Um oh, hold on. IK dot left. IK dot right. Constraints. Add constraint. Hold on. In was oh. Oh. Why is that bending backwards now? It's because I moved the bone, isn't it? Because I moved the bone. Oh boy. What if I just add a new bone? Okay. dot left, and then ik dot right. That mirrors, and then select that. Um, um, Strengths, child of. That does not work. Wonderful. Um, well, damn. What if I just read the manual? Oh, I'll hide that for now. Do, 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 do. Introduction. Next. Blender provides set of vectors. Frames, curves, now linear actions, drivers, video sequencing, tracking, the animation pipeline. Each of the editor serves a different purpose. Scope sheet. Because it manipulates keyframes. NLA editor. Drivers editors. The clip editor. Playpad. I don't have any music playing. What happened to the music? There we go. sync option. Is that in preferences? Um, can I open up a second copy of the manual and then search sync options? Physics. Cache panel is used to bake the fluid simulation. Stores the outcome of the simulation. Replay only works when the playback sync mode is set to play every frame. If you need to use frame dropping or synced audio, consider the modular all options. No. Sync playback. Wait, hold on. That brought me that brought me back to here. 3D viewport. Oh, okay. That didn't answer my question because I didn't read enough. I didn't read enough. Story of my life. Didn't read enough. Oh, wait a minute. Wait. It's right here. So while I was doing video editing, I could have just had it so that it allowed frame dropping. So that I could. Oh. That would have been helpful to know. It probably works the same in the video editor. Oh man. Okay. My spine hurts. Just put me under, doctor, and give me a new armature. The flesh is weak. I crave the strength and certainty of steel. Uncheck the mute mode audio. Frame rate. Playback follow current frame. Huh. Okay. So that automatically pans the view to catch up with the playhead when it goes off screen. Okay. Okay. Learning new things. Going places, learning new things. It's great. I love it. Is unchecked. And update once playback stops. The name of this pop buffer will change depending on the active key set. Playback keying. Okay. Control tab. I don't know what I was staring at right there. I got lost in my head and the music was good. Sorry. Keying. I didn't see any keying, so active keying set. Keyframes, that was one of the things I wrote on my sticky note that I still don't understand. Insert keyframes. Keying set is named collection. Animatable count. Predefined keying set. Also create your own keying set panel. I is insert keyframes, Alt I is delete keyframes. Wonderful. Cycle aware key. By inserting keyframes into trivially cyclic curves, special handling is applied to preserve the cycle integrity, most useful while tweaking an established cycle. Okay, I will pretend to know what that means. If a key insertion is attempted outside of the main time range of the cycle, it is remapped back inside the range. When overwriting one of the end keys, the other one is updated accordingly. In addition, adding a new curve to an action with a manual frame range and cyclic animation enabled, the curve is automatically made cyclic with the period matching the frame range for convenience. And conversion is done before adding the second keyframe to such a curve. The record button is enabled. Hold up, that's a record button? Oh, hold on. Oh, okay, that is a record button. Okay. Found a record button. Wonderful automatically create keyframes on the current frame whenever you transform an object or bone in the 3D viewport, or change one of its transform properties in the properties editor. One special use case is to record a camera path as you fly through the scene. See fly/walk navigation. Okay, hold up. So that means that what I could do is, hypothetically, I could fly using the camera, control tilde. Alt tilde? No. No, alt tilde is something else. Camera. How do I get out of the camera? Oh no, how do I get out of the camera? Tilde? View camera. Okay. Control tilde was the thing that got rid of the gizmo. Hold on. Okay. That button reveals and hides the gizmos. Control tilde also hides the gizmos. Shift tilde? Yeah, it was shift tilde. Okay, backspace. Camera, shift tilde? Oh, okay. So hypothetically, I could hit the record button and then just fly like this? And then just like... Wait, hold on, what would that accomplish? Read the manual. Reading manual. Record button. One special use case is to record a camera path as you fly through the scene. Okay, so it will... So the keyframes that will be generated would be the keyframe light path of the camera. Using the record button. Am I understanding that correctly? Oh, okay. Okay. That kind of makes sense. I'm working on it. I'm working on it. When the record button is enabled, Blender will automatically create keyframes on the current frame whenever you transform an object or bone in the 3D viewport, or change one of its transform properties in the properties editor. One special use case is to record a camera flight path as you fly through the scene. See fly/walk navigation. Auto-keying only works for transform properties, location, rotation, scale. It won't create a keyframe if you change, say, the color of a material. You will have to do that manually. Okay. Okay. I believe you, Manuel. I believe you. Manuel relay instructions. Yeah, that is in fact relayed instructions. Load add markers. Recording adds a new NLA track for every pass made over the animation to allow non-destructive tweaking. I'll do my best to pretend to know what that means. Transport controls. Use these buttons. These buttons are used to set the current frame and control playback. Start. Jump to previous keyframe. Rewind, shift spacebar starts playing the animation in reverse. Spacebar starts playing the animation. Stop, pause. Jump to next keyframe. Jump to end. Jump it backward by delta. Menu accessible. Jump by delta buttons. Their delta can be set. Oh. Okay. Well, there we go. That's another thing. The number of frame. So Alt scroll wheel. Okay, Alt scroll wheel does in fact change the frame. Wonderful. Oh boy. Keyframes is gonna be a long section. Introduction to keyframes. A keyframe is simply a marker of time in which stores the value of a property. For example, a keyframe might define that the horizontal position of a cube is at 3 meters on frame 1. The purpose of a keyframe is to allow for interpolated animation, meaning, for example, that the user could then add another key on frame 10, specifying the cube's horizontal position at 20 meters. And Blender will automatically determine the correct position of the cube for all of the frames between 1 and 10. Depending on the chosen interpolation method, linear, Bezier, quadratic, etc., an overview of existing keyframes can be seen via the dope sheet editor. Okay. Brain is getting fried. However, that explanation is an explanation. There are some important visualization features in the 3D viewport that can help animation, and the current frame is a keyframe for the current active object. The name of this object shown in the upper left corner of the 3D viewport turns yellow. Okay. That makes sense. Hopefully. Maybe. Kinda. I'll have to sleep on it. I'll have to sleep on it. I'll have to sleep on a lot of things. But I'm getting better every single day. Hopefully. I think so. I think I'm getting better every day. If I'm not, at least I'm not drinking and smoking myself to death, or apathy, or anything. I am, in fact, jaded. I will take as much boring reading as I can. Because if I can find enjoyment in the most boring things possible, hopefully I won't be sprung onto, you know, manic or depressive episodes. And my eyes are glazing over. Oh no. I just have 10 more minutes. 10 more minutes, and then I gotta go to work. Let me get through some more. Interpolation. Keyframe interpolation is represented and controlled by animation curves. also known as F-curves. These curves can be viewed and modified via the graph editor. Okay. Constant linear quadratic Bezier interpolation with linear extrapolation. Constant linear quadratic Bezier interpolation with linear extrapolation. I think. Picture says 1,000 words, so I guess I've read a couple thousand words at this point, hopefully. The x-axis of the curve corresponds to time, while y represents the value of the property. Keyframes themselves define points of the curve, while interpolation is controlled by additional parameters. The interpolation mode is the main setting that specifies for each keyframe how the curve is interpolated from that key to the next one. There are a number of modes with fixed shapes, e.g. constant linear quadratic, and a free-form Bezier mode. Is it Bezier or Bezier? Extrapolation specifies how the curve extends before the first and after the last keyframe. The main available choices are constant and linear. It is also possible to configure the curve to loop. Bezier interpolation is controlled by handles, which have a handle type and position. The position of free and aligned handles must be set manually from the graph editor, while vector, automatic, and auto-clamped handles are computed automatically from keyframe values. Interpolation, extrapolation, and handle type can also be changed from the dope sheet editor. So it can be both in the graph editor or the dope sheet editor. Handle smoothing modes: red, none, green, continuous acceleration. Okay. Right, my spine. My spine. My spine. This would have been even worse if I didn't have this chair. Ergonomic office chair is better than any gaming chair. Eat your hearts out. Pink Hearts of Iron players. I don't know. Never played Hearts of Iron. The method how the three automatic handle types are computed is controlled by the per curve auto handle smoothing setting. The none mode resembles how most other software works, only considers the values of the immediate adjacent keys. The continuous acceleration mode considers the shape of the whole curve, which produces smoother results out of the box, but means that changes in one key affect interpolation over a larger section of the curve. It also tends to overshoot more with automatic handles. Keyframe types. For visually distinguished regular keyframes, for visually distinguishing regular keyframes from different animation events or states, extremes, breakdown, or other in-betweens, there is the possibility of applying different colors on them for visualization. Keyframe white/yellow diamond, normal keyframe. Breakdown small cyan diamond. Breakdown states, example for transitions between key poses. Moving hold, dark gray/orange diamond. Okay, a keyframe that adds a small amount of motion around a holding pose. In the dope sheet, it would also display a bar between them. Extreme big pink diamond, an extreme state, or some other purpose as needed. Jitter tiny green diamond, a filler or baked keyframe for keying on ones or some other purpose as needed. Generated dark diamond, a key generated by some tool, for example, copy global transform fixed camera. This keyframe type indicates to Blender and add-ons that it is safe to remove and regenerate them, so be careful when manually making your free-made animations with this type. Handles and interpolation mode display. Group sheet can display the Bezier handle type associated with the keyframe and mark segments with non-Bezier interpolation. These facilitates basic editing. This facilitates basic editing of interpolation without the use of the graph editor. The icon shape represents the type of Bezier handles belonging to the keyframe. If the handles of a keyframe have different types, or in case of summary rows representing multiple curves out of the available choices, the icon that is furthest down the list is used. This means that if a grouped row uses a circle icon, it is guaranteed that none of the grouped channels have a non-auto key. Horizontal green lines mark the use of non-Bezier interpolation. The line is dimmed in summary rows if not all grouped channels have the same interpolation. Display of this information can be disabled via the Show Handles and Interpolation option of the Dope Sheets view menu. Okay. And I guess I'll be editing keyframes at some other point because I'm just about to hear my alarm go off for me to go to work. So, and that's hitting the 2-hour mark. So I would managed to do 2 hours of streaming. 2 hours of streaming is good. I like 2 hours of streaming. 10 a.m. to noon. I can do that. I'll do weekends and Mondays and Fridays. That's just how it's going to have to be. I do have a full-time job. It is a stressful full-time job. But I also have to have time for myself in order to do like grocery shopping and adult things. Apparently I have to do adult things. Ain't that weird? Ain't that crazy? I don't like it. I hate the fact that I have a corporeal form. If I could go through life and not have a physical body to take care of, or need to have like breaks in order to prevent burnout when I want to try and learn as much of new concepts as possible, that would be great. However, I can't. I am mortal, unfortunately. I am unfortunately mortal. So that's a whole different thing. So I'll see everybody at some other point. Bye-bye.